Good. So welcome once again to our class at Brainwave, where we demystify mathematics, right? So today we're going to be talking about inverse of a matrix. Inverse of a matrix. Inverse of a matrix. So what's the inverse of a matrix? The inverse of matrix is denoted by this symbol over here. So if you have a matrix A, then this will be the inverse of the matrix A. Now, a good thing to note is that if we multiply the matrix, the inverse matrix, with the matrix itself, I'm going to get the identity matrix. And for a 2 by 2, the identity matrix is just 1 0 0 1, which we have discussed in the previous video. You can check it out. Then for a 3 by 3 matrix, it's going to be 1 0 0 0 1 0 0 0 1, right? Just the leading diagonal have element 1 to be precise. Now, if I multiply the matrix with the element, it's the same thing as multiplying the inverse with that particular matrix, and I'm going to get the inverse. This is certain. So for example, if I have a matrix, if this is my matrix A and is equal to 2 1 5 and 3, right? If I multiply it with a matrix, I don't know the matrix, so name the matrix. Let's say the matrix is A, B, C, D, which we are going to look for. Then this should give me the identity matrix 1 0 0 1, right? Good. So basically, this particular matrix, if I'm able to obtain the values of A, B, and C, they are going to be the element of this inverse matrix. While here we have the identity matrix. Fantastic. So let's try and multiply this matrix together. Now we are multiplying row by column. I want to get the element in the first row and first column. I'm going to take the first row of first matrix, multiply it against the first row of the second matrix. So we have 2a plus 1 multiplied by c, which is just c, right? Taking the first, multiplying the second. So we have 2 multiplied by b. This will give me 2b. 2b plus d, because 1 multiplied by d is just d. We want to get element in the second row, second column. So we have 5 multiplied by a. We have 5a plus 3c. We have the last element there will be 5 multiplied by b, which is 5b, plus 3 multiplied by b, which is 3d. Now this should give us the identity matrix, which is 1 0 0 1. Fantastic. Now what do we have to do next? We can compare these equations, right? So 2a plus 2a plus c is equal to 1, right? So from here we got 2a plus c is equal to 1 from this. So let's consider this also. We now have 5a plus 3c is equal to 0, right? So what can you see from here? From here we can actually make, let's just consider these two equations. From this first equation, let's name it equation 1 and equation 2. We can solve this simultaneously, right? I think we can solve this simultaneously. So you can pick any form, but here I will go with, let's multiply here this equation by 3 and multiply this equation by 1, so that here will tally. So multiply here by 3, I have 6. So this equation now will automatically become 6a plus 3c will be equal to 3, while the second equation remains the same, right? Plus 3c is equal to 0. So if I subtract this equation, I'm going to have 3 minus 0 will be 3. So 3c minus 3c will be 0. So 6 minus 5a, I will just get a. So my a here is 3. right? So I've gotten the first element in that my matrix. So I have it to be 3. Good. Now, similarly, I can now consider the second equation. The second equations we have, let me pick this one. So here I can consider 2b. So we have 2b plus d is equal to, this one should be equal to 0, right? So why this one is 5b plus 3d should be equal to 1. So likewise, I can do the same multiplication here. I can multiply here by 3, right? If I multiply here by 3, multiply here by 1, I can eliminate d. So like here I have 6b, this should be plus 3d will be equal to 0. Then I have 5b, right, plus 3d should be equal to 1. So if I subtract this equation together, 6 minus 5 is going to be b, 3d minus 3d is gone, so 0 minus 1 is equal to minus 1. Fantastic. So here I'm going to have b should be somewhere here, minus 1, right? Good. So I've gotten a, I've gotten b. So I can substitute a into this place to get c, since 2a plus c is equal to 1. So which means if I'm making c the subject formula here, I'm going to take 2a to the other side. So c is going to be 1 minus 2a. So let's calculate for c here. It's going to be 1 minus 2a, right? But do you remember that my a was equal to what? 3, right? So evaluating c now will be 1 minus 6, which is going to be minus 5, right? So my c here is going to be minus 5. Good. Then my d rather, so d here, I can get d from this particular point. Can you see? 2b plus d is equal to 0. So I can just take 2b to the other side of the equation. So my d will now become minus 2b, right? b. So what is b? We have gotten b here as minus 1. So instead of writing b, I can simply put minus 1. So automatically 2 minus 2 minus 1 multiplying each other, I'm going to get 2. So here basically I'm going to get 2. Fantastic. I'm going to get 2 for D, right? So obtaining this result, so which means automatically this particular diagram here is for my, this particular matrix there is for my inverse of the matrix. Can you see how easy it is? So I have found the inverse of this matrix. So you see this matrix, if I multiply this matrix with the initial matrix that we have used, so this matrix, if I multiply this matrix, what it simply means is that if I multiply this matrix over here with this matrix over here, I'm definitely going to get the identity matrix, right? So this matrix multiplying this matrix is going to be the identity matrix, and automatically this is matrix A, which is now called the inverse, matrix A inverse. So let's do a quick check and see if we are actually accurate. So you can always check. How can I check? It's very simple. I multiply matrix A. I can multiply matrix A, multiply with A inverse, right? I'm going to get the identity matrix. So let's check. Our matrix A was 2, 1, 5, 3. Then our matrix inverse is 3 minus 1 minus 5. Then 2. Good. So this should be equal to 1, 0, 0, 1. Now let's multiply and see if it is true. So we have 2 multiplied by 3 should give us 6. Then plus 1 multiplied by 5, which is minus 5. Then for this entry over here, we have 2 multiplied by minus 1. This is minus 2 plus 1 multiplied by 2, this is 2, right? So 5 multiplied by 3, this should give us 15. 15 plus 3 multiplied by minus 5 is minus 15, right? So we have lastly 3 multiplied by minus 1. Lastly, for this entry, you have 5 multiplied by minus 1. You're going to get minus 5. 2 multiplied by 3 over here, you're going to get plus 6. So upon evaluating, can we see we're going to get 6 minus 5. We're going to get 1. 2 minus 2 is 0. 15 minus 15 is 0. Minus 5 plus 6 is 1. So we are actually on point. Is correct, right? This is perfectly done, quite easily done, right? This is perfect. Now we move further to so many other integrals, to so many other matrices, right? So we can pick another generalized form of obtaining the inverse of a matrix. Now, when I say generalized form, I just simply means we can pick any particular matrix and decide to get the inverse, right, directly from that particular matrix, right? So for any given matrix, we have the inverse to be given in the form of changing the diagonal element and negating the other part. Like if you look at it very well, you can see that all we need to do is to just interchange them, the diagonal element, while the other side we negate them. That is just what we have, right? So to find the invert, the element on the leading diagonal are interchanged, then multiply the other element by minus 1, then divide the result by the determinant of the initial matrix. It's straightforward, right? So you can do that simply. What do I mean? You just have to change the element using the leading diagonal, then multiply the other element by 1. The element in the leading diagonal don't multiply anything, but every other element multiply them by negative 1, then divide the result by the determinant of the matrix. For instance, in our case, our determinant was what? 6 minus 5. And that's how we got 1. So let's try and see if we can get a generalized form of obtaining the 2 by 2 inverse of a matrix. Now, the best way to do this, I can use the concept of using variables, right? Assuming I have my matrix A, I have matrix x1, x2, x3, x4, right? This is my matrix, and then I have let's still stick with A, B, C, and D, right? Now we know that this is supposed to give us 1 0 0 1. This is a generalized form. So I want to get with alphabet, I want to use algebra. So upon multiplication here, I have x1 multiplied by a, so I will have ax1 plus cx2 is equal to 1 over here. Then similarly, I'm going to have b. Take the next one, we're going to get what? In this part, b x3 plus dx4 is going to be 0. The dx of it going to be 1 also, this particular element. Then check this other element. What are we going to have there? We have b of x1, then here we're gonna have plus d of x2. This should give us 0. Then lastly, let's pick the other element, a of x3 plus c of x4. This should give us 0 also. So consider all this equation, right? Let's consider all this equation. This particular equation, let's multiply the equation 1, this first equation, multiply it by d and see what we will obtain. So if multiplying that equation by d, we're going to have straightforward ad x1 this plus what c dx2, then this should be equal to d, right? Then let's try and multiply the other equation by c equation by c, this particular equation over here. Let's multiply by c. So if we multiply that equation by c, we're going to have bc x1, right, plus cd x2. This should be equal to 0, right? Why are we doing this? We want to factor out x1 and x2 at the end of the day so that we can get a solution for them. And then similarly we are going to do for the second equation, right? So these two equations, now if I decide to subtract them, right, if I try to subtract the second equation from the first one, so let's subtract this one, right? So what we're going to have here is, let me write it properly. We're going to have what? We're going to have a d x1 minus b c x1 is going to be equal to, we're going to be having that particular is equal to this minus this, right, is going to be equal to d, right? Because so now we can factor out this particular term. So we're now going to have x1, let's by factoring, should be, what is remaining here is ad, then what will be remaining here is bc, that's going to be equal to d. Fantastic, right? This is fantastic. Then similarly we have gotten that for x1, right? So if we're getting that for x1, then x2 is going to be what? If it is x2 we want to get, how can we do that? X2 is going to be what? X2 is very straightforward, right? We're going to get x2 in terms of taking this and this. So x2 is going to be c d x2 minus, right, c b c c dx2 and then c dx2. This is gone, right? Then this is that. So for the second part of the equation, if I want to get for x2 now, let's go and see what we have. Where can I use to get x2, right? I can decide to take out where do you have x2 again? X2 is here and x2 is here, right? So if I'm taking out x2, I'm going to have x2 to be equal to x2 should be equal to minus b upon AD minus BC. Similarly, if I do the algebra properly, I'm going to get x3, which is equal to minus C upon AD minus BC. Then x4 is going to be A upon AD minus BC. You can always pause the video to see how we got all the elements, but it's very straightforward considering these particular equations over here, right? Considering all these equations that are here, this equation, this equation, this equation, and this equation, right? So considering them, I can take these two equations together. We already have the values. So here we have A11, we have C is over here. So you can see that all you need to do is to multiply this same equation by A and B, right? If you multiply this equation by A and B and subtract, you're going to get the result that we have gotten. I don't want this video to be so short. So in generally, if you have this particular equation, you come to discover that if I now put in all the values, if I decide to put all the value of A and x1 up to x4, I'm going to have x1 looks somehow like, let me bring it down, is what it was like D upon AD minus BC, right? So bringing all of them together, you come to understand that you're going to have D over here. I'll put all over what? AD minus BC. Similarly, for this other guy, I'm going to have minus B all over what? AD minus BC. Then for this other guy, I'm going to get minus C all over AD minus BC. Then for this guy, I'm going to have D all over AD minus BC. So what can I do? I can factor this out, right? So if I decide to factor this out, what am I going to get? I'm going to get that I have 1 all over AD minus BC. If I factor it out, what I will be left with will be D minus B minus C, and then we have A. Now this is straightforward. You can observe that AD minus BC is just like our determinant. For instance, do you remember we have A, B, C, D? How do you get determinant of this? A multiplied by D, A multiplied by D minus C multiplied by B. Can you see that? So can you see that is the same thing as what we are having here? So basically, the inverse of a matrix is this, right? So the inverse of a matrix, if you want to get that matrix, is just 1 all over the determinant of the matrix, then multiply by this matrix, interchange the leading diagonal. So I have B and then A, interchange the other one too. So I have here, I don't need to interchange the other one. All I need to do is just to negate the other one. So I have minus B and then minus C. So I'm interchanging the diagonal, negating every other element, dividing by the determinant of that matrix. In our case, is matrix A. This automatically becomes the inverse of the matrix. And it is similar to 3 by 3, but the issue is that, so first of all, we are supposed to get the adjoint of the matrix, where we'll be talking about the minus. How do we get the minus? Remember, for our 3 by 3 matrix, we have plus, minus, plus, minus, plus, minus, plus, minus, plus, right? So for each of the elements, you have to get the minor. What do I really mean? The cofactors. They are cofactors if I have this element over here, let me use example 1 2 1 4 6 7 2 minus 1 and 0. If I want to get the cofactor of each of the elements, so the cofactor is also going to be a 3 by 3 matrix. It's also going to be a 3 by 3 matrix, but I will consider this sign. So if I want to get the element that is supposed to be here using this matrix, now I have to take out here and take out here, right? I'm left with this part. So I'm going to do it. 6 multiplied by 0 is 0 minus into minus 1 multiplied by 7. This is a minus 7. So here minus minus is positive. So this element for the cofactor, the element that is going to be here is going to be 7. Right? I'm going to get a 3 by 3 matrix of the cofactor. But for this guy, I know that it's going to be negative, negative. So negative what here? Negative 2. Negative, you don't consider this. All you consider is just the cofactor, the minus. So negative into, if I take out this, what is going to remain? It's going to remain 4072. So I'm going to have negative into 4 multiplied by 0 is 0 minus into 2 multiplied by this is 14. So you come and put the answer here. That's how you put for all of them. You're not taking determinant. It's just you're just doing them one after the other. So after getting this, you will now get the adjoint. Then you divide by the matrix to get the inverse of a 3 by 3 matrix. So by the next class, I'm going to be doing a clear example of a 2 by 2 and 2 by 3 matrix. But we have done the generalized form, and we also want